Welcome. In this video, we will learn one of the most important parts of logic, truth function and propositional logic. We will understand how statements are connected, how symbols make reasoning easier, and how truth tables help us test whether an argument is logically correct. Let's begin with the basic building block of logic, the statement. A statement, also called a proposition, is a sentence that is either true or false. It cannot be both, and it cannot be neither. For example, the earth revolves around the sun is true, while 2 plus 2 equals 5 is false. Since every logical argument is built from statements, understanding them is the first step in learning logic. Statement can be divided into simple and compound statement. A simple statement expresses only one idea and contains no single connector. For example, it is raining. A compound statement combines two or more simple statements using logical connectives. For example, it is raining and the road is wet. Now let's learn about the connective that join statements together. Logical connectives are words that connect statements to create compound statement. The five main logical connectives are negation, conjunction, disjunction, conditional, biconditional. Each connectives change the relationship between statements in different way. We will study them one by one. The first connective is negation, represented by the symbol look like anchor or wavy line. Negation simply means not. It changes the truth of a statement to its opposite. For example, if the statement is the light is on, its negation becomes the light is not on. Negation always reverses the truth value of a statement. The second connective is conjunction, represented by the symbol look like reverse V. It joins two statements using the word and. For example, it is sunny and it is warm. Conjunction is the true only when both statements are true. If even one statement is false, the whole conjunction becomes false. The third connective is disjunctive, represented by the symbol look like V. It joins statement using the word or. For example, I will read a book or watch a movie. In logic, this usually means at least one statement is true. A disjunctive is false only when both statements are false. The fourth connective is the conditional, represented by the arrow. It expresses an if-then relationship. For example, if it rains, then the ground becomes wet. The first statement is called the antecedent and the second is called the consequent. The conditional is false only when the first statement is true but the second statement is false. The fifth connective is the biconditional, represented by the symbol left-right arrow. It means if and only if. For example, a figure is a square if and only if it has 4 equal sides and 4 right angles. Biconditional is true when both statements have the same truth value. They must either both be true or both be false. So far, we have worked with ordinary language. However, long sentences can become confusing. To avoid ambiguity, logicians use symbols. This system is called symbolic logic, and it allows us to express argument clearly and precisely. Let's see how it works. In symbolic logic, each simple statement is represented by a letter such as P, Q, R, S. For example, P. It is raining. Q. The road is wet. Instead of writing the full sentence repeatedly, we can simply use this symbol to represent them. Now let's translate ordinary language into logical symbols. It is raining and the road is wet become P conjunctive symbol Q. It is not raining become negation P. If it rain, then the road is wet become P conditional symbol Q. Using symbol make logical argument shorter, clear and easier to analyze. Logical expressions are created by combining statement symbol with logical connectives. For example, start first bracket P connective symbol Q first bracket close conditional symbol R. This expression means if both P and Q are true, then R is true. First bracket are important because they show how different parts of an expression are grouped together. Now that we know how to write logical expression, we can test whether they are true or false. A truth table is a systematic method for finding the truth value of a logical expression. It lists every possible combination of truth values for the statement involved and show the result for the entire expression. Truth table help us understand exactly how logical connectives work. To construct a truth table, we first list all possible truth values for the basic statement. Then step by step, we calculate a truth value of each part of the expression until we reach the final result. This organized approach removes guesswork and makes logical analysis precise. A tautology is a logical expression that is true in every possible situation. No matter what truth values the individual statement have, the entire expression always comes out true. Tautologies represent statements that are logically granted to be true. A contradiction is the opposite of a tautology. It is a logical expression that is always false, regardless of the truth values of its individual statement. Contradiction reveal impossible or self-defeating logical form. Some logical expressions are neither always true nor always false. These are called contingencies. Their truth depends on the truth values of the individual statement. Sometimes they are true and sometimes they are false. Most everyday statements are contingencies. Truth tables are also used to determine whether an argument is valid if there is no situation where all the premises are true while the conclusion is false. If such a situation exists in the truth table, the argument is invalid. This makes truth table a powerful tool for evaluating logical reasoning. If you are still watching, I hope you are finding this content useful. Please like and share this video, subscribe to the channel and share your thought in the comment. Your support motivates me to create even more content like this.